All right, welcome back. So here is where we're going to get into the factor theorem. So in the previous examples that I've done, I've pointed out that, hey, in some of those cases we got a remainder of 0, and that means that the resulting quotient is a factor of the original polynomial, but also that the divisor is also a factor, right? And so now, and then coupling that with the idea, and that comes from also looking at the remainder theorem, right, that we talked about before, then we can come up with the factor theorem, which basically states this. It's very, again, straightforward, and it's biconditional. So it says, let f of x be a polynomial. All right, so that means if it's a polynomial, then we have we basically have this. 1, if f of c equals 0, which means the remainder theorem, right, says, hey, we can find the remainder by evaluating the function at that c value. If we evaluate the function and we get 0, which means, again, by the remainder theorem says that, oh, the remainder is 0. So in other words, if we have this, f of c equal to 0, then what we can know is that x minus c is a factor of f of x. But also it goes the other direction. If we know x minus c is a factor of the polynomial f of x, then we also know that f of c has to equal 0. And that's the factor theorem. So we're going to use the factor theorem to help us determine things like factors and zeros and things like that.